first kind of hardware-accelerated demo that we showed at Mix in March of this year. And this is a Web 1.0 application, a Web 2.0 application. This uses standard JavaScript, standard HTML4, and standard CSS, the same type of web capabilities that we had in 1995. And the way that this works is, you can see that I'll move my mouse around, the JavaScript tracks my current mouse location, and it spins some divs around the screen. I can hit plus a couple of times to increase the number of images. And you can see that I'm sitting at 60 frames per second, which of course most monitors in the world, most displays are 60 hertz, so 60 frames a second is the real-time graphics. This blew away web developers. And the power of this really comes from two things: compiled JavaScript and the GPU-powered graphics itself. Internet Explorer 8 was able to get 2 frames a second for this exact same demo. And we're now achieving 60 frames a second without even really pushing the CPU or the GPU. This is kind of really helping lighten web developers. One of the demos is we built in partnership with IMDb, the Internet Movie Database, which shows the HTML5 video tag. So I'll go ahead and click play here. And you'll see that I have high definition video inside of the browser itself. So this is high def H.264. Looks like the 18 trailer. All through standard web platform capabilities. I can speed up, I can rewind, I can pause the video itself. I can do callbacks from JavaScript into the video to get kind of play time. So go ahead and close that. This is kind of the start of the HTML5 rich media capabilities. And this is all enabled through one video tag called video in the browser itself. The same way you would have an image tag in HTML4, you just have a video tag in HTML5. Tag, which uses Canvas. Canvas is an immediate mode 2D graphics API. And you can see here that we have 20 fish in IE9 at 60 frames a second. And on this machine, I'm going to go ahead and go up to 50 fish, 100 fish, 250 fish. Let's try 1,000 here. You see when we hit 1,000, we start to drop down in terms of frame rate a little bit on this particular machine. But I have 1,000 fish flying around. This is entirely possible thanks to, again, compiled JavaScript and GPU-powered graphics. Doing something like this on the CPU, you'd be sitting at 1 to 2 fish, of course. Is asteroid belt. And you can see that I can move my mouse around, and the images can track, again, using that same 2D drawing surface. You can see very different from the websites that you experience. Great. So this is psychedelic browsing. Another one of our test-type demos that's a lot of fun. This is also using the 2D Canvas API and some of the core graphics primitives in the new model. One of the things I wanted to touch on here is we've also fully hardware accelerated all text on the web using the direct write set of APIs. So all of the text here, again, is also being drawn from the GPU. You also get great kind of sampling around the characters and subtext positioning, subtextual display. This one I'll show you real quick. We'll see how this performs on my dual monitor screen here. But what this does is it takes a color wheel, and it sees how fast it can start spinning that color wheel. And of course, once you get up to 60 frames a second, at full speed, the colors start to kind of blend together. And then we slow down the color wheel. The fully hardware accelerated version of Firefox. It's the latest. And I'll go ahead and run speed reading here. Speed reading, oh, and I'll actually turn on. The audio here. If you've seen kind of the train board, you know, train schedules or flipboards dropping in train stations, speed reading kind of uses that same animation technique to display different characters, different sayings on the screen itself. And then kind of starts this test to see how long it takes to say all of those different phrases. You can see it's still clearing here. And again, the fully hardware accelerated, or the hardware accelerated version of Firefox is still clearing the screen and it's getting ready to display the start of the test. So we'll be ready, set, go. Inside Firefox, this takes about 9 minutes to complete on this machine. The Chromium nightly build. This is actually Sunday night's build of Chromium with hardware acceleration enabled. Their default configuration. I'll go ahead and put speed reading. And you can see some debug information along the bottom. So the first is kind of this debug draw, total number of draws, and then how long the average draw takes. So you can see the average draws take about 15 milliseconds here. I won't force you guys to sit through this, but this same demo takes about 13 minutes, about 13 and a half inside Chrome. Again, let's look at this demo inside IE9. Okay, you ready? So you'll notice a few differences. You'll notice on the bottom, the total billboard draws is moving much more quickly, and that our average draw time is much lower. Let's start the test. There's the spontaneous applause that I was waiting for. Again, the same demo inside IE9 takes about 14 seconds. Probably about 14 minutes. Not 11 on this machine. 11 seconds on this machine. So that's the difference.